hi everyone from my side. So give me a short introduction. So I'm Nico Meisenzahl. I'm Senior Cloud DevOps Consultant at Vortrag. We are a company in southern Germany near Munich. I'm a Microsoft MVP, a Docker community leader, and GitLab Hero. I'm doing stuff around Kubernetes, DevOps, cloud, mainly focused on Azure. Yeah, so what I will talk about today. So first of all, I will talk about why do we need Kubernetes. Then doing some minutes of how Kubernetes actually works, just some basics to get everyone on the same level. And we'll then talk about container services on Azure. So AKS and some others around. And then in the last part, if we have some time, we'll do a short demo. Cool, so let's start over. First of all, why do we need Kubernetes? So before we talk about Kubernetes, let's briefly talk about containers itself. So with containers, we have some kind of nice functionalities. First of all, we have an isolation. So a container itself is not more than just an isolated process on our machine, so which allows us to run multiple processes next to each other on a single machine without any trouble, anything dependencies between the processes each other. So this first one, isolation. Second one, dependencies. So with our container, which is just an isolated process, we get the opportunity to change the underlying file system, which is so-called container image. So we can provide a container image with our process. The container image itself includes everything the process needs. Could be an operating system, could just be some binaries, and so on. So with this in place, we can define the dependencies of our process and make sure the dependencies are met. And then, of course, scalability. Our process is completely isolated. All dependencies are within our process itself, our container. And with that, we are able to just scale out the container as we need them. Pretty nice so far. And our last one, we have immutable containers. Immutable containers means, and this is once again related to the container image, that every instance we start will look the same. So we have a container image, which is basically our template we're creating a container instance from. And this one is looking the same all the time. So if we start 10 instances, all the 10 containers will look the same. So, but it's immutable. So these are the main reasons why we should choose containers and love the containerized microservices, containerized applications. Yes, so, but with container, we also have some kind of issues, or they're not yet production ready if we do just containers. That's why we need something else which helps us bringing the production level on top. So first of all, we need to manage those containers. We might need to scale them, so have the opportunity to scale them or automatically scale them, and we need to monitor them. So if the process running, do we need to restart the containers and so on. Then as example, once again, we somehow like to scale the containers. We would like to scale them across multiple nodes, which if we go for Docker Plain or Docker Compose, it's completely restricted to one node, to one machine only. So we need something to scale out across multiple nodes. If we scale out a container workload, we somehow need an option to do load balancing and service discovery. So think about, we have 20 different containers running, and we need something in front to be able to, load balance or provide IP addresses, DNS entries, and so on to have service discovery in place. Then, of course, self-healing. So we would like to know when a container process stopped working or had some issues or getting trouble. We'd like to know this and maybe to automatically stop or kill the container and restart a new instance. And then last but not least, we somehow need any configuration management, secret management, storage management if you somehow would like to get any kind of state. Yeah, so these are the main reasons why containers itself are not yet production ready, and we need something on top. So there's where Kubernetes comes into place. So Kubernetes itself is basically an open source system, which helps you automating your deployments, scaling your containers, and manage them in any kind of reasons. And the important Kubernetes is doing this with a declarative approach. Now, this basically means, and it's on the next slide, basically means that Kubernetes, we tell Kubernetes what we would like to have, and Kubernetes is doing it. So we are defining, as I described in the example, we say, hey, Kubernetes, please run my application with 3 instances. And then Kubernetes will do everything needed to run those 3 instances. And we do not tell Kubernetes how to do it. We just say, hey, we would like to have 3 instances of our app, and Kubernetes is doing it. So the last line, if one of the instances dies, Kubernetes will itself know it after some seconds, because we have some kind of monitoring in place, and will then decide to kill the container and restart a new instance. So Kubernetes will make sure that every time 3 instances are running. And it's nothing I need to do. It's basically just I think I would like to have 3 instances, and Kubernetes will do so. Yeah, so some basic facts about Kubernetes. So first of all, Kubernetes, the word is Greek. It basically means helmsman or captain, which is pretty nice because a helmsman is nearly doing the same like Kubernetes. So on a big ship, the helmsman is not doing the actual work, just the helmsman tells his crew or the autopilot or anything else to do the work, or tell I would like to drive in this direction, and the ship is doing the same. So Kubernetes was introduced by Google in June 2014, so it's some years old now. And then after open sourcing it, actually was hosted or provided to the Cloud Native Computing Foundation, which is a part of the Linux Foundation, to get a nice open source foundation. And then after providing Kubernetes to the Cloud Native Computing Foundation, Microsoft, IBM, Red Hat, and Docker joined the project 6 weeks after the first release. And then most of the big players contributing to Kubernetes. Kubernetes was not the first container management tool built by Google. There are 2 more, Borg and Omega, which are both internally used at Google and not open sourced. And Google itself decided, instead of building a third one for their use cases, they decided to build Kubernetes and provide it to the world out there. And yeah, to be honest, at the moment, Kubernetes is the only the containerized orchestration tool. There are other out there, but mostly all of the world is using Kubernetes so far. So let's switch over to the Kubernetes basics and learn about how Kubernetes works. First of all, we have pod. So the smallest instance in our Kubernetes environment is a pod. It's not a container. That's very important. So a container itself can have a pod itself can have a container in it, or multiple ones. So in this case, we have our main process, this one, which is really the container image we would like to run, and we would like to define our main process, our application. And then we have some kind of other containers around. So we have an init container on the left. The init container is used to provide basic functionalities in front of the main process. So you can define in the container if you would like to do that stuff before the main process is started. So think about configure the environment, creating database tables, and so on. Everything which your main process needs, but you don't like to have it on your main code. Really nice feature about init container is that the init container needs to finish successfully before the main container gets started. Then on the other side, we have the so-called sidecar containers. Sidecar containers are containers which live next to your main process and allow you to add additional functionalities. So think about log management, log forwarding, or if we talk about a service mesh world, most of all service meshes out there are putting their managed proxy as a sidecar next to your main process. So anything related to HTTP proxies or log management would live in a sidecar container. And then we have the network interface for the pod itself. This one is just the IP address. The pod gets internal in the Kubernetes cluster to communicate with other services. And this one is actually also a container, which is just providing network interface and mapping the IP address. So if you have the smallest possible pod, you will have the network container as well as the main container. And this is why the smallest instance is a pod and not a container. So then we are talking about the pod, or I had already talked about the pod with one or two or multiple containers in it. Now we would like to schedule our application itself and make sure that the application is running. So that's why we are not deploying just the pod configuration in our cluster. If we do so, our application would run, everything would be fine. But Kubernetes would make sure that the pod gets restarted or scaled in any kind of reason. So to do so, we need a resource called replica set. So this one here. And a replica set will then make sure that a pod is scheduled to the count we define. So if we define we would like to have 4 instances, the replica set will make sure that 4 instances are running all time. To be 100% clear, it's not the replica set itself. It's the replica set controllers, and there are some kind of controllers, which is basically small microservices, which listen to the API and doing things. So in case of the replica controller, if a new replica resource is created or changed, the replica controller will review the resource and will define steps to do. So at least maybe schedule another pod because one was killed, or scale out because we changed the instance count, or things like that. So the replica set and the replica controller are making sure that our instances are made. And then around here, we have the deployment configuration. The deployment configuration is mainly the part we're really acting with. So if you create or would like to deploy our app, we are most of the time deploying deployment instead of a replica set or a pod. Why are we doing though? Mainly because the deployment adds an abstraction level on top of the replica sets. So if you think about upgrades, so you would like to change to a newer image version or a completely new image, and you would like to do it without any downtime, this is where the deployment and deployment controller comes into place. So basically, if you have a deployment and you would like to upgrade it, you're defining a new tech version or image version, which then happens is that the deployment controller creates a second replica set. So we're getting 2 replica sets within our deployment, and within every replica set, pods are scheduled. So we have the old replica set with the old version of the pod and the containers, and we have the new replica set with the new pod and the new container image version. And then, at least if the default configuration is used, the new replica set is scale up, and the alt replica set is scaled down. And if it's 0, the replica set itself will be deleted. And this is done to make sure that there's no downtime when upgrading our deployment. Now, this is the whole story about why we use deployments and not replica set to make sure we do have online updates. So now we have our deployment running, which basically means we have our app running in 5, 4, 3 instances, but we somehow would like to communicate with other services. This is where cluster IP service comes in place, which is used for the internal communication. So I think about we have the pod up here, which is our service A. And then we have some other kind of pods which are scaled out with our application B. And if application A would like to talk to application B, the pod wouldn't directly talk to the application B pod. It would talk through a service. And this service is basically IP address and DNS entry in our Kubernetes cluster, which is aware which pod is available and is able to get traffic. So if this pod is talking to this service, the service will make sure that the requests are routed to the pods which are basically available and able to respond to the request. And this is how the whole internal communication is done. But we maybe also would like to expose our application to the internet, or at least to outside of our Kubernetes cluster. And this is where the Node-Pod service comes in place. The Node-Pod service adds some stuff on top, and it's basically exposes our application, our internal service through high ports on every node. So in this example, we have 2 nodes. We have node 1, node 2, and every port. It doesn't matter if the application and the pod, the container itself is running on this node. So it's on every node in the cluster, high port will be exposed to the outside. And this communication from this high port will then be routed through the internal service to our pods and containers. So this means I'm the user from the outside of this node would now be able to access the application using the high port and will get routed to the actual pod. This is, of course, not pretty nice. In a normal world, you would then put a load balancer or proxy in front to get rid of the high ports, to get load balancing and stuff like this. So this is why we in the Azure world or in any cloud world, we normally do not use the Node-Pod service, but it's the basic underlying stuff which we are using in the next example. So if you're using Azure, you're basically using the load balancer service to export your services. And the load balancer service is the same like the Node-Pod, as I mentioned here. So it also exposes the high ports to the outside world. But then instead of getting me the opportunity to manually adding any kind of load balancer or proxy, Kubernetes itself will talk to the Azure Resource Manager and will register Azure Load Balancer and automatically configure it. So if we're creating a load balancer service within our Kubernetes cluster, Kubernetes will talk to Azure and will request a load balancer, which gets automatically configured. So then this load balancer is listened to AT and 443, and then routing the request to the nodes on the high port, and this one gets then routed to the cluster to the actual pod and container. No, this is the actual opportunity to export any kind of application. And this works with a load balancer and an external IP, public IP, as well as an internal load balancer, which is located within a subnet or your internal VNet. Then on top, we have a so-called ingress resource, which actually isn't a real service. It's basically an HTTP proxy, which is listen on a load balancer port. So once again, we have our load balancer, but then with Ingress, our traffic is not directly routed to our application. It's routed to any kind of HTTP proxy. If you deploy the default configuration, it's Nginx, but any kind of proxy is possible here. So would be also possible to add Azure Application Gateway in this case. And then with this, you have between your load balancer and your actually application, you have an HTTP proxy, which you then can use to redirect traffic. Like in this case, I have foo-domain.com, which is redirected to service A. Then I have domain.com/foo, which is directed to other service. And then I have a wildcard, which is redirected to a third service. Which is also possible with an Ingress is to define TLS, which then means you can add and terminate TLS at the Ingress level and also add certificates which are managed by Kubernetes, which is once again pretty nice. So load balancer is used to expose one single application. Ingress is used to expose multiple applications, and they have multiple options in rewriting all stuff. Yeah, then the big picture for Kubernetes. So we have once again on the upper side we have our master nodes, and below we have our worker nodes. In Azure world, the master node is completely managed, so you don't need to care about anything. You just get your API server address, which you can talk to talk to the API, get your resources, create resources, and then everything else is completely managed for you. In the API, in the master server, we have the controller manager. Like I said, those controller listen to the API and doing stuff like the deployment controller, replica set controller, and so on. We have the scheduler, which is scheduling our pods. So scheduler is deciding when a pod is scheduled on which node it should get started. And we have etcd as our persistent storage. So it's a key value database where the API server stores the state. This is the master node. On the worker node side, we have multiple workers, which basically means multiple virtual machines, where our actually workload is located. So here are pods scheduled and running, and we have some further smaller stuff. We have the kubelet, which is basically the communication to the API server, which then actually schedules the containers and pods on the local machine. We have CAdvisor, which is collecting metrics and forwarding them to API server, and we have kubeproxy, which is used for the actually exposing on the node that user is then able to access the node itself. Yeah, so resources, like I said, deployment, replica sets, pods, and all the other ones are defined in YAML or JSON and using a declarative approach. As an example here, on the right side, we have a deployment, and we define we would like to run one replica based on the image Nginx. In this case, latest, because I did not add an image tag. And this is it. So if we would like to scale up manually, we would just change the replica to 456, and then the API server or Kubernetes itself would scale up and run new container instances. So when we create such a configuration, we first of all need to create it locally or use a CLI, which I talk in the next slide. This YAML or JSON definition is then passed to the API server, which is validating it and then processing it and storing it in the state store. And then the controllers are acting on it. So if I save deployment configuration, the API server will not do anything else than validate it and then store it. And then the controllers would start working on it. So the deployment controller would say, yeah, okay, deployment, I need to create a replica set. And then the replica set would create the pods and so on. Yeah, so how do I work with Kubernetes? First of all, we have a nice CLI, which is kubectl, kubectl. There are different names for it, and this one is used to do at least anything. It's available for Windows, Mac, and Linux. I can get, create, and delete resources. I can access any kind of API resources and details. I can use kubectl to attach into a container if I would like to debug the container. I can use port forwarding, so I can forward a container port locally on my machine that I can access the container port with localhost and attach a debugger or things like this. And it's extensible, so if I would like to include plugins or write my own plugins, I can do so. Then, of course, there's a dashboard. It's this one on the right corner, which I can use if I would like to have a graphical interface. And then there are multiple and thousands tools which help me working with Kubernetes resources or deploying Kubernetes resources. As example, would be Helm or Customize, which help me with deployments, but it's a completely different story. Yeah, so these are the somehow container basics. So let's talk about how containers work on Azure. So we've got different services on Azure. First of all is the Azure Container-Registry, ACR, which is a full managed and scalable container registry. So once again, completely managed. We have integrated security, so we can use our Azure AD credentials to authenticate, and then can define role-based access, so who is allowed to do what, read images, push images, delete images, and so on. Azure Container Registry is also able to build containers. So you don't need to build them locally and then push them into the registry. You can tell a container registry to build them for you. This can be done via Azure CLI. So you can use Azure CLI on your local machine using the same syntax as we use for Docker build. Just do a acid, ACR build, providing your Docker file, your working directory, and then your whole code is uploaded into the Azure Container Registry, and your container image is scheduled, is built in the cloud. Azure Container Registry also supports OCI images, which basically means that you are not only able to store container images, but also store some other kind of stuff. As an example, Helm charts. Helm is a application management tool which allows you to build customizable and shareable deployments. And you can also share those using the container registry. The pricing itself is based on the service tier and your usage. So it depends, and it's also fully integrated with Azure DevOps. Yeah, some more examples. Azure Container Registry is also able to do image scanning. So with the premium service tier, you are able to test and security scan your images after building them. But there are also third-party options which could be integrated. So with this, you can make sure that your container image doesn't have any security issues before using it and deploying it into your clusters. Then, of course, geo-replication, which means you can access your Azure Container Registry from different locations and always use the nearest location nearby, the fastest location to get your images and work with them. So in this example, in Europe, you would access a data center in Europe, get your image, and then can use your continuous delivery pipeline and deploy it into your AKS cluster. So this was container registry. Then we have container instances. Container instances are a lightweight option to run containers in Azure. without thinking about anything except your container image itself. So it basically means it's somehow a serverless service. You're just providing your container image, defining how you would like to scale it, and run it. And you do not need to think about it anymore. So it supports Linux, Windows on GPU workload, and it's perfectly used for any kind of event-driven applications. So if you need to scale something on an event, you can use container instances, or for some kind of batch job, data processing jobs, nightly jobs, so anything which just runs for one jobs and then needs to be stopped. Azure Container Instances would be a nice option. Which is also pretty nice is that container instances can be integrated with Azure Kubernetes service. This is something I will talk later in detail, but basically for faster scaling or compute isolation. Yeah, and then Azure Container Instances are pay as you go based on CPU and memory usage. So Azure Kubernetes service itself, I think it's one of the mostly or biggest services in Azure and most be used services. It's a fully managed Kubernetes cluster. As that on the big picture of Kubernetes, the master nodes are completely managed. You don't need to think about them. You don't need to do anything. Azure Kubernetes Service is scalable and secure by default. Also runs Linux, Windows, and GPU workload, and allows a nice end-to-end developer integration. So you have a tool or function like Azure Dev Spaces, which allows you to completely move your development inner lifecycle into Kubernetes. So instead of building and debugging locally, you can build and debug your application in your inner loop in a Kubernetes cluster with different options. Yeah, and then we have Visual Studio Code integration, pretty nice. So it's really nice integrated. Pricing is based on your compute, so just paying for your worker nodes, not the master node. And for your worker nodes, it's just a virtual machine, so you need to pay this kind of virtual machine. So Azure Kubernetes Service integrates perfectly with the whole Azure world. So we can use Azure Monitor for monitoring. There's a container solution, which is called Container-Instances, which gives you deep insights on the containers. You can integrate it with Azure Policies for governance, Azure Files, Azure Disks for persistent storage, Active Directory authentication for authentication and authorization. You can integrate AKS in your virtual network. You can use Application Gateway for encrypted security, Key Vault to store your secrets. You can integrate it with Azure DevOps for CI/CD, and also it's of course integrated in the Azure portal for easy administration and easy access. But just as an overview, let's jump in some of the examples with some more details. So one would be Azure AD and the role-based access control behind it. So with AKS, you can authenticate with your Azure AD user. So you're just authenticating using the Azure CLI, and then getting a token, which is mentioned here. So you're authenticating and then getting a token back. And with this token, you then can access your Kubernetes cluster via kubectl, via dashboard, and so on. And then when you're authorized and able to access your Kubernetes cluster, you can then define roles within the cluster and map those to the Azure Directory user or group. And then you can tell, okay, my group should have write access to all deployments in our cluster, and so on. So you define who, which resource, and what the user is allowed to do. So pretty nice integration with Azure AD. Then we have cluster autoscaler and virtual nodes. So let's focus on the left side. It's cluster autoscaler. especially mean you have your Azure Kubernetes service running, and you have, let's say, one pod, one node running, and you would like to scale out your pods, but you don't have enough compute to do so. Then those pods would be scheduled but never started, so they would still be pending because there's no compute where the pods can be started. Then the cluster autoscaler could scale up our AKS cluster, which basically would add a new virtual machine, would add the virtual machine to the virtual machine scale set, and integrate it in our Kubernetes cluster. And with this in place, we would then have enough compute to run or schedule the new pods. Pretty nice option to scale out, but it took some time. So it's basically requesting a new VM and adding this new VM into our cluster, which can take 1, 2, 3, 4, 5 minutes, depending on the time. So this is where virtual nodes comes in place. So virtual node thing I mentioned before with Azure Container Instances, and virtual node allows us to integrate Azure Container Instances with our Kubernetes cluster, which then mean we could scale into our virtual node, which means Azure Container Instances, and scale out there, which then is just a scale out of seconds. So if you have a peak in your application, you would like to scale out in seconds, you can do with Azure Container Instances. With a normal cluster autoscaler, you would scale after the peak already finished. So you have those different kind of options. Then, of course, there's the option to use a private cluster, which means normally your API, Kubernetes API endpoint is exposed on a public IP. This can be changed via the private link feature to map or expose this API endpoint into an internal subnet. And the same for your services. If you expose the service, normally it's a load balancer which then gets a public IP, but it's also possible to expose the service using an internal load balancer, which then can be mapped in one of your subnets. So it can be configured to be totally private. Same for any kind of other platform as a service services in Azure. So if you would like to have a container registry privately within the same subnets as your Kubernetes cluster, you can do so. And also with storage services like Azure Files or SQL or anything else, or Cosmos DB. Then I already mentioned it. There's a container insight solution which can be added to log analytics and then used with Azure Monitor, which provides you with deep insights on your containers and your Kubernetes cluster. So also pretty nice feature to get all the monitoring metrics details you need. And then you can use it, as you know, with log analytics, with Azure Monitor, alerting, and so on. There's also an option to add your own metrics using a Prometheus integration if you would like to. So then we can also integrate Azure Policies for governance reasons. So it's possible to decide Azure Policies which then affect your AKS cluster. Think about you would like to only allow certain container registries or trusted container registry and make sure that no Docker images, container images are pulled from Docker Hub. You can either lock down the egress of your AKA cluster to permit it on a network level, but you can also use Azure Policies and only allow certain container images, container tags, container registries. And then once again, in the background, there's a controller which then checks every deployment and decide whether it's allowed to scale or not. Yeah, then another security feature is the integration of Azure Key Vault. So you can use Azure Key Vault to store your secrets and then use those secrets in your container. Basically, this is an integration which needs to be set up before you can use it, but then you can inject your secrets or your keys using either files or environment variables into your container and then use it. So you don't need any kind of secrets to configure it. So it's a pretty nice and secure way to inject your secrets. There's also from Kubernetes side, the user called secret, which allows you to store secrets, but it's not 100% secure. So it's best practice to use any kind of key vaults, and with this you get a nice integration of Azure Key Vault. So it's perfectly and pretty nice and secure. Yeah, and last thing is Azure AD Pod Identity, which is a little bit bigger and complex thing, but basically Azure AD Pod Identity allows your container to authenticate with other Azure services. So let's say you have your application and your application needs to talk to a SQL server. Then normally you would need to provide the secret into the container, and then the container has the secret to talk to and authenticate against the Azure SQL server and then talk to it. With Azure Active Directory Pod Identity, the pod itself is authenticated and allowed to talk to Azure SQL service. So you don't need to add any authentication within your application code. The authentication is done on a pod level. So the pod is allowed to talk to the Azure SQL server, and you don't need to do anything related to security on your own. So it's a pretty nice feature. In the background, it's based on node managed identities, if you know them, with virtual machines and so on. So it's basically the same, but it's added to a next level on the pod level. So pretty nice feature. A little bit complex to set up in the first tries, but if you have it running, it's really nice and abstracts all the security and authentication stuff with Azure services. So pretty nice. So then, as a last point, I would have a short demo, but I think we are already pretty late and have only 3 minutes left. So I think I would skip this one and open up for questions. So also slides are already published. So if you would like to get slides uploaded to SlideShare, but you can also review this session on YouTube. So do we have any questions?
Yes, we have. First of all, thank you very much for a very interesting session, Nico. We have one question, and I think that's also a good one to follow up on this session as well. And that is, where is the best place to start with learning AKS for someone who is new to AKS? Okay, so for AKS itself, I would go to the Azure documentation. So pretty nice examples which you can use and try out. Maybe also the Kubernetes documentation itself on Kubernetes.io, if you would like to learn more about Kubernetes itself. So those both would be helpful, I guess.